Welcome to a lesson with Dr. Powell. Let's take a look at graph transformations. Let's look at a function written with y as the output is equal to 2 times the square root of 3x minus 1. Then we have a plus 1 here. This looks a lot like y equals square root of x, but some changes have been made algebraically. We're going to investigate what happens geometrically as well in the change. First, let's look at the graph of y equals square root of x, 1/2 of a sideways parabola. Now, I'm going to put boxes here. And we have this axis, the x-axis with a box, this axis, the y-axis with the box. Now, you notice how I did that? Let's see why. First, let's take this and rewrite this, subtract 1 and divide by 2 to see that this equation can be written the same way, with boxes. With the square root of box is equal to box. This is quite telling because if we take a point on this graph, such as 1, 1, so you put 1 in the square root, you get 1 out. That means that if this quantity is equal to 1, then that quantity better be equal to 1, just like I have that point. What if I have the point 4, 2? Then that means that if the quantity inside the square root, 3x minus 1, is equal to 4, then this quantity outside is equal to 2. So this is quite nice. That means that all I need to do to draw the graph is just to change the name of the axes, and then I could call it quits, but we're not. Okay, 3x minus 1, y minus 1 over 2. So then that means this point, this 4, refers to a 3x minus 1 value, not an x value, but a 3x minus 1 value. It's equal to 3x minus 1. This 2 represents a y minus 1 over 2 value right here. Okay, this tells us quite a bit because the question now is, how do we transform this picture to look like the picture we want, where this is an x-axis and this is a y-axis? It really amounts to saying you're taking all of these points and how do you change them, like this 4, how do you move from this 4, which is equal to this whole expression, down to x? It's the same thing as how to move from the square, from the inside of the square root symbol to x. What's the pathway to get from right in here, the whole expression 3x minus 1, to x? That actually tells us exactly what the transformation should be, at least for x. The same thing would happen for y as well, from here, and what's the path to y? But we're going to be lucky in that case because that path is actually the same path that we have over here when we solve for it. And computationally, notice what's the first thing you do on the outside of the square root is you multiply by 2 and then you add 1. It's all present. But in this case, moving to x, we have to unravel for the 3x minus 1. Let's take a look at how this is going to look. Okay, so let's just look at the original now, since we have some motivation. We start at the square root, which represents the old function. The inside of the square root, that path to the x computationally is going to give the x transformations. The computational path that goes from the square root to the y on the outside is going to give the y transformations, or the vertical transformations. So let's first do horizontal. So right inside the square root is 3x minus 1. Let's look at the path of this to x. What needs to happen? Well, first you need to add 1. That's like adding 1 to the old x value on the old graph, because this is the old x value. This is equal to the input of the square root. So you add 1 to it, but then what do you have to do? You have to divide by 3 or multiply by 1/3. So this is like taking an x value, adding 1. That means it's a shift to the right. Then you take all your x values and you multiply by 1/3. That means compress. Okay, Now, what about vertical? Okay, vertical transformations. Let's look at this pathway from the square root to the y. First thing it's done to the square root is multiply by 2. So we think multiply by 2. That would be stretch by 2. So if you multiply all your y values by 2, look what happens. You're stretching that way and that way. If you have a y value, multiply it by 2, it stretches it up. Have a y value, multiply it by 2 down here, it stretches it that way. Similarly, this is a compression, because if you take an x value, multiply by a third, it gets it closer to the y-axis. So it compresses toward the y-axis. This run right here compresses compresses away from the x-axis. This compresses toward the y. This stretches away from the x. Okay, so multiply by 2 is the first thing right on the outside of the square root. What's the next thing? We add 1. So if you add 1 to all your y values, what are you doing? You shift up. Okay, now let's see what that looks like in a graph. All right. So let's start with our original. That's y is equal to the square root of x. Now, let's first do horizontal. Okay, so next, it looks like we're going to shift to the right by 1. And next, we're going to compress by a third. So that means we're going to take this and multiply it by a third. So bring it in, all these x values, you're going to take a third of them. So it's going to look something like it's been compressed, multiplied in this way. Okay, so we've been successful with the horizontal transformations, where this is now at a third, because we had shifted it right to the 1, and then we multiplied by a third in. Okay, next, what about the vertical? What's done vertically is you take this graph and you stretch it by 2. So it's going to be stretched. So we'll do that right here. Stretch it. So if we stretch it, it's going to be come a little, stretch it that way. And then we shift it up 1. And that would be the graph. Now, if you want to know where individual points travel, you can actually just follow these guidelines here. Like on the original graph, there were some points. On y equals square root of x, there's a point 0, 0. Where does it travel? We'll just follow these on the x's and follow these on the y. So on this 0, add 1, and then multiply by a third. That would give you 1/3. Now, for the y, take this, multiply by 2, that's 0, and add 1, that's just 1. This tells you that the point 0, 0 travels here, which makes sense. Right here, this point should be 1/3, 1. Okay, now where does the point, let's look at the point 1, 1. Where does the point 1, 1 travel? We'll just follow these for the x. So 1 plus 1 is 2, multiply by a third, so 2/3. What about this one? Multiply it by 2 and add 1. That would give you 3. So that would mean that I would have another point here, which would be 2/3, comma 3. So I can get points on this graph simply by looking at the transformations, if I will, knowing where the destinations of the original points to the new points. Thanks for watching.